Welcome to our deep dive, everybody. It's all about engineering ethics this time around.
Ooh, very cool.
Yeah, it should be really interesting. We've got some classic textbooks we're going to be looking at
Okay.
and some real-world case studies. Should make you think a little bit.
Nice.
Yeah. So we're going to go way beyond just nuts and bolts.
Okay.
And we're going to really explore how the choices engineers make impact, everyone's lives.
Yeah, that's what's really interesting about engineering ethics, I think,
Yeah.
is that it's not just the technical stuff.
Right.
It's kind of this bigger picture.
Yeah.
The social impact, the human impact
Yeah, for sure.
of what engineers actually create and build.
Okay, so let's start with the basics.
Okay.
What exactly makes engineering a profession? Our sources kind of go into all these different perspectives on this.
Yeah.
It's actually pretty interesting.
Yeah, one way to look at it
Okay.
is through like a sociological lens.
Okay.
So this focuses on things like, the training, the specialized skills that engineers have, the fact that they often have a monopoly on providing certain services,
Okay.
and their level of autonomy in the workplace.
So like how you need a licensed electrician
Right.
to rewire your house.
Exactly.
You trust them because of their training and
Yeah.
all the regulations around their profession.
Exactly.
Yeah, okay.
And then there's this idea of like a social contract view.
Okay.
So this suggests that professions have like an unspoken agreement with society.
Okay.
They provide their expertise.
Right.
They commit to ethical conduct.
Mm-hmm.
And in return,
Yeah.
they get public trust and things like, higher compensation.
So it's a two-way street.
It is.
Society relies on engineers to design safe bridges, safe buildings, and engineers in return are held to this higher standard because lives literally depend on their work.
Precisely.
Wow.
And our textbook actually throws in another interesting perspective from an ethicist named Michael Davis,
Okay.
who suggests that professionals choose to come together to serve a moral ideal.
Okay.
So it's beyond just meeting like the bare minimum requirements of the law or market forces.
Interesting.
It's about striving to actually make a positive impact.
So they're motivated by something bigger than just a paycheck.
Absolutely.
I like that.
Yeah, and this leads directly into the core of engineering ethics,
Okay.
which is this responsibility engineers have.
Right?
Our textbook really stresses this,
Okay.
highlighting this like paramount obligation engineers have to put public well-being first.
It's easy to think about safety when we talk about engineering, but it goes even further.
It does.
Doesn't it?
Yeah, it expands to include things like quality of life,
Okay.
even sustainability.
Wow.
So think about projects like those undertaken by Engineers Without Borders.
Okay.
They're using their skills to create clean water solutions
Right.
and improve sanitation in developing countries.
Okay, now that's using your powers for good.
Yeah, absolutely.
It really shows you the positive impact that engineers can have.
Totally.
Speaking of tackling these big problems,
Yes.
our sources bring up the grand challenges
Oh, yeah.
identified by the National Academy of Engineering.
I've heard of these.
Yeah, so these challenges represent these really ambitious goals,
Okay.
like ensuring access to clean water for everyone,
Wow.
restoring and improving urban infrastructure,
Okay.
and even creating like personalized learning tools.
So these are all areas where engineers can, really make a difference.
A huge difference, yeah.
That's pretty inspiring,
It is,
that engineering can contribute to solving some of the world's most pressing issues.
for sure.
But our textbook doesn't shy away from the downsides of technology either.
No, it doesn't.
It's not always,
Well,
sunshine and roses.
Yeah, it's important to remember that technology can be a double-edged sword.
Right.
Even with the best intentions, there can be unintended consequences.
Like, they use a great example in the book.
Yeah.
The evolution of the bicycle. Oh, yeah.
Remember those old high-wheel bikes?
I do.
Designed for speed?
Right.
But society ultimately favored that more practical design
Yeah.
with smaller wheels. So it shows how societal values actually influence technology choices.
It's a great illustration.
Yeah.
It highlights the need for engineers to think critically about what they're creating.
Okay.
Are they developing tools that actually enhance lives? Or are they sacrificing important values for the sake of progress? It's a question every engineer needs to grapple with.
That's a really good point.
Yeah.
It's about making those conscious choices, not just blindly pushing technology forward.
Exactly.
But let's say an engineer wants to make those ethical choices.
Okay.
What happens when they face an actual dilemma
Right.
where different values clash?
That's when things get even more interesting.
Okay.
Our textbook provides some practical tools for navigating these situations.
Okay.
One approach is what's called the line drawing technique.
Okay. So imagine you have these clear examples of what's ethically right and wrong. This technique helps you to compare a morally ambiguous situation to those examples to figure out where it falls on the spectrum.
So you're kind of creating a scale to help you assess how ethically sound a decision might be.
Exactly.
Okay, cool.
Another approach is seeking creative middle way solutions.
Okay.
So it's about looking for a compromise that satisfies or at least minimizes the conflict between those competing values.
Gotcha.
For instance, there's a case study in the textbook about a young engineer named Brad who is concerned about the lack of proper design checks at his company.
Oh, that sounds like a disaster waiting to happen.
Right.
Yeah.
He's torn between speaking up, which is, his responsibility,
of course,
and remaining loyal to his employer.
Classic ethical dilemma. So how does he even start to figure out what to do?
That's where tools like line drawing and creative middle way solutions can be super helpful. They can help him to find a way forward that both upholds his ethical principles, but also allows him to fulfill those professional duties.
Right.
It's not always easy, but there are ways to navigate those situations.
So it's like having a toolkit to tackle those tough ethical calls.
Exactly.
But before you can even use the tools, you need to know what your ethical foundation is.
Right.
Right? How do engineers even determine what's ethical in the first place?
That's where different ethical frameworks come in.
Okay.
One major framework is utilitarianism, which focuses on achieving the greatest good for the greatest number of people.
Gotcha.
It's about maximizing happiness and minimizing harm.
So like that whole trolley problem thought experiment?
Exactly.
You have to decide whether to switch a runaway trolley onto a track with one person to save 5 people on another track.
Yeah, you're forced to confront your moral intuition there.
It's hard.
It is.
Do you prioritize saving more lives even if it means causing harm?
Exactly. Yeah, it makes you think about how you weigh different outcomes and make those choices.
Okay, so that's one framework.
Another framework is the ethics of respect for persons. This emphasizes treating individuals as ends in themselves, not just means to an end. You value each person's inherent dignity and autonomy.
So you're not just using people to achieve a goal. You're actually considering their well-being, their rights as individuals.
Exactly.
The textbook actually highlights this with a story about an engineer who showed real leadership by putting the well-being of his team and the community first, even when it meant delaying a project.
Wow.
That's a powerful example.
It is.
Of how ethical leadership goes beyond just following the rules. It's about having that strong moral character.
Absolutely.
Okay, cool.
And speaking of character, the concept of responsibility in engineering is so complex. Our textbook really digs into things like accountability, liability, and all these different factors that can hinder responsible action. It even delves into psychology.
Interesting.
Referencing experiments like the Milgram experiment.
Wait, really?
Yeah.
What's that?
Where participants were shockingly willing to follow orders.
Really?
Even when they believed they were inflicting pain on others.
Oh, wow, that's terrifying.
It is. It shows how powerful authority can be. And raises all these questions about how engineers can hold on to their own moral compass. Especially when they're facing pressure from higher-ups.
Or within their organization.
Exactly.
So it's not enough to just know what's right. You need the strength to actually do it even when it's hard.
Absolutely.
Oh, man.
And the textbook drives this point home by analyzing these major engineering failures. Like the Challenger disaster.
Oh, wow.
Remember that?
Of course.
Engineers had warned about the dangers of launching that space shuttle in cold weather. But their concerns were ignored. And tragedy struck.
It's a stark reminder of what can happen.
It is.
When warning signs are overlooked and ethical considerations take a backseat. Chilling example.
It is.
Makes me think about the importance of trust in engineering.
Our
sources talk a lot about how honesty, confidentiality, responsible handling of intellectual property. These are all crucial for building and maintaining trust.
Yeah, it makes sense.
Because lives depend on engineers being truthful.
Exactly. Reliable. Think about it this way. Imagine you discover a serious safety flaw in a building that's about to be sold. You're torn between your duty to your client and your responsibility to protect public safety.
Oh, I can already feel those ethical gears turning in my head.
It's a tough call.
Yeah.
And our sources delve into real-world scenarios like this.
Okay.
They don't offer easy answers.
Right.
But they do provide this framework for thinking through those dilemmas, using those tools we've discussed.
Okay, so we've got the ethical frameworks. We've got some tools to tackle those dilemmas.
Yeah.
But it seems like there are so many potential minefields in the world of engineering. Our textbook brings up expert witnessing, where engineers are called upon to give testimony in legal cases.
That's right.
That can get ethically murky fast.
It can.
What happens when the evidence doesn't support your client's case? Do you have an obligation to disclose that information?
Right.
Even if it could hurt your client?
That's a really tough spot to be in.
Yeah.
It is.
I can see how prioritizing honesty and integrity would be paramount in that situation.
Absolutely.
But it seems like honesty goes beyond just the courtroom setting.
It does.
Our textbook also talks about the engineer's responsibility to inform the public.
Yes.
Especially when there are potential safety concerns.
That's a crucial point.
They use the example of the Ford Pinto.
Oh, yeah.
A car with a design flaw that made it prone to explosions. Right.
And rear-end collisions.
Yeah. Ford executives knew about the flaw.
They did.
But they chose not to fix it.
Seriously?
Because they believed it would be cheaper to pay out lawsuits than to recall the vehicles.
Wait, what? They put profits ahead of people's lives?
It's a tragic example of how prioritizing profits over safety can have these devastating consequences.
Yeah.
It really underscores this moral obligation that engineers have to speak up when they see something wrong.
Right.
Even if it means challenging their employer.
So putting public well-being above those corporate interests.
Exactly.
Wow, okay.
And this ties into the broader discussion in the textbook about this sometimes difficult relationship between engineers and managers.
Oh, yeah, that classic clash of cultures.
Right.
Engineers laser-focused on safety and technical excellence.
Yeah.
And then you've got managers often prioritizing budgets and deadlines.
The next book really delves into the ethical challenges that can come up.
Because of this tension.
Okay.
For example, what happens when a manager pressures an engineer to sign off on a project they know is unsafe?
That's a good question.
They use a real-life case study.
Okay.
The story of Ernest Fitzgerald, who was fired by President Nixon for exposing cost overruns on a defense contract.
Wow. So he was punished for trying to do the right thing.
It highlights the importance of what's called responsible dissent.
Okay.
Engineers need to be willing to stand up for their professional judgment.
Right.
Even when it means challenging those in positions of authority.
Yeah, it reminds me of the Challenger disaster again, where engineers voiced concerns, but they were ultimately overruled by managers focused on that launch schedule.
It's a sobering reminder that organizational pressures can lead to these really serious ethical lapses.
Yeah, the textbook even quotes a phrase from that case. Take off your engineering hat and put on your management hat.
It's a chilling example of how ethical considerations can get brushed aside for expediency.
It really makes me wonder how we can create a culture where engineers feel empowered to speak up, where their voices are heard and their concerns are taken seriously.
That's key.
Yeah, it seems like that's so crucial for preventing these kinds of disasters from happening again.
It is. It's an ongoing challenge.
Yeah.
But it's a conversation we need to keep having.
Absolutely.
Speaking of challenging conversations, let's shift gears and talk about the complexities of engineering ethics on a global scale.
Yes.
Our textbook dedicates a whole chapter to global engineering ethics.
And it seems like that's where things can get really ethically complicated.
You're right.
Yeah.
Engineers working in other countries often encounter these different cultural norms and practices that might clash with their own ethical framework.
Like we talked about before, nepotism might be frowned upon in one culture, but be considered totally acceptable in another. Or there might be different expectations around gift giving, which could be seen as bribery in some contexts.
Yeah, how do engineers navigate those gray areas?
Yeah, how do you balance respecting local customs with upholding your own ethical standards?
That's a great question.
Is there a right answer?
The textbook explores different approaches.
Okay.
From rigidly sticking to your own ethical standards.
Okay.
regardless of the context, to simply adopting the practices of that host country.
Okay.
Ultimately, they advocate for finding that creative middle way.
Right.
We've talked about that before.
Finding a way to respect other cultures while also staying true to your own ethical principles.
Exactly.
It sounds like a delicate balancing act.
It is.
For sure.
And they use a case study to illustrate this.
Okay.
Imagine an engineer working in a developing country.
Okay.
Discovers that a factory is polluting a river.
Okay.
But shutting down that factory would put a lot of people out of work.
Right.
What do? It's an ethical dilemma.
Ooh, wow. That's a tough one.
With no easy answers.
Yeah, you're caught between protecting the environment and protecting people's livelihoods.
Exactly.
Yeah, there's no easy answer there.
It highlights the importance of dialogue.
Okay.
Listening to and understanding different perspectives.
Yeah.
And being willing to think creatively. To find those solutions that minimize harm.
Right.
But also respect the needs of everyone involved.
It sounds like global engineering ethics requires this whole other level
it does.
Of cultural sensitivity.
Yes.
And the ability to think outside of your own cultural bubble.
Absolutely.
Yeah.
And as our world becomes increasingly interconnected, these skills are going to be more and more essential for engineers.
So we've talked about the importance of trust.
Yes.
The challenges of working with managers and the complexities of global engineering ethics.
Yeah.
It's clear that engineers face a wide range of ethical dilemmas.
They do.
Throughout their careers.
Absolutely.
Yeah.
And it's not just about avoiding harm, but also about actively promoting well-being.
Okay.
For individuals and for the planet.
That brings up a huge challenge for engineers.
Yeah.
Sustainability.
Big one.
Our sources really dig into that tension between protecting the environment and promoting human development.
Yeah, it's this constant balancing act.
It is.
How do we meet the needs of this growing population without depleting resources or damaging the environment?
And there are so many different viewpoints on what clean even means. Our textbook talks about the maximum protection criterion, which argues for eliminating any identifiable risk to human health, no matter the cost.
That sounds pretty idealistic.
It does, right.
Is it even realistic?
It seems like it would be incredibly expensive and maybe impossible to achieve.
And then you have the other end of the spectrum. The demonstrable harm criterion. This one says we should only focus on pollutants that have been proven to be harmful.
But wouldn't that be reactive?
It would be.
Rather than proactive.
Yeah, we might not discover those harmful effects until it's too late.
Exactly. It feels like we're missing that sweet spot, that middle ground, where we're being responsible, but also pragmatic. Thankfully, our textbook offers a potential solution. Life cycle analysis.
Life cycle analysis?
That's a much more holistic approach.
It is.
Instead of just looking at one point in time, you evaluate the impact throughout its entire life cycle.
From raw material extraction to manufacturing to use and disposal.
It forces you to think big picture.
For sure.
And consider those long-term consequences.
Yeah, and it's not just theoretical.
Right.
The textbook highlights some really cool examples. Of companies actually using this to make a difference. They talk about 3M's pollution prevention pays program, which has saved them millions of dollars by reducing waste and pollution.
So sustainability can be good for business, too.
It can.
It's not just about doing what's ethically right. It can also be about making smart, cost-effective decisions.
Absolutely.
Okay, so we've got these practical approaches, like life cycle analysis. But what about the mindset? Behind sustainable engineering, our sources talk about cultivating respect for nature.
That's a crucial point.
Yeah.
It's not just about meeting regulations. It's about recognizing the inherent value of nature, our interconnectedness with it.
And there's a growing body of research that shows how spending time in nature can benefit us in so many ways.
Reduces stress, improves cognitive function.
Even boosts physical healing.
It's amazing how connected we are to the natural world.
Even if we spend most of our time indoors. So protecting the environment isn't just about saving the planet for future generations. It's about improving our own lives right now.
Absolutely.
Our textbook suggests that engineers can play a huge role.
For sure.
In fostering this respect for nature.
By designing solutions that connect people to the natural world. engineers can make a difference.
Imagine buildings with integrated green spaces.
Yeah.
Bringing nature right into our urban centers.
That's a great image.
Or transportation systems that minimize their impact on the environment, but also provide opportunities for people to enjoy the outdoors.
It's about creating a future where technology and nature can coexist.
I love that vision.
It's a good one.
It brings us back to the core of engineering ethics. Using your skills to make the world a better place.
Absolutely.
It's about more than just following rules.
Right.
It's about shaping a future that is sustainable and just...
I like that.
It's a call to action.
It is.
To think big, to be innovative.
For sure.
And to consider the impact of your work on the planet and on people's lives.
Okay, let's get back to those specific ethical challenges.
Okay.
One area that's ripe for dilemmas is trust and reliability.
It's fundamental to any profession.
It is.
But especially engineering.
Honesty, confidentiality,
Right.
responsible handling of intellectual property.
These are all cornerstones of trust.
They are.
And in engineering, where decisions can have life or death consequences,
Right.
that trust is essential.
Absolutely.
It makes me think about those stories.
Yeah.
You hear about bridges collapsing or buildings failing. It often comes down to a breakdown of trust.
It does.
Whether it's shoddy materials or cutting corners or just failing to speak up.
Right. And the textbook doesn't just focus on those big cases.
Okay.
It talks about honesty in everyday situations.
Okay.
Even on a college campus.
So not just outright cheating,
Right.
but things like taking credit for group work or fudging data.
It's a reminder that ethical behavior starts early.
It does.
Those small acts can have a ripple effect,
Right.
eroding trust, impacting the integrity of the whole profession.
The textbook presents a case study
Okay.
about a professor who unknowingly submitted a paper,
Oh, wow.
co-authored with students
Okay.
who had fabricated data.
That's a tough situation.
Yeah, the pressure to publish,
Mhm.
to achieve success,
Right.
could lead to bad choices,
It could.
but it comes down to integrity.
It does.
It raises questions about the responsibility of mentors
Yes.
to guide their students to create an environment where ethical conduct is valued.
Absolutely.
Ethical challenges can pop up at any stage,
They can.
from student to seasoned professional.
And sometimes those challenges can be tricky.
Okay.
Like when an engineer discovers a safety issue in a building
Right.
right before it's sold.
That's a good one.
The textbook has this scenario
Okay.
where a client actually threatens an engineer to keep quiet
Oh, wow.
about defects.
What would you even do in that situation?
It's an ethical pressure cooker. It pits their loyalty to the client against their duty to public safety.
Would you risk your career to do the right thing?
It's a tough call.
It is.
The textbook doesn't offer easy answers,
Right.
but it encourages engineers to use those ethical tools
Okay.
to navigate these situations.
So it's not about having a script
Right.
for every scenario,
Yeah.
but having a framework to
Yeah.
help you make the most ethical choice.
Absolutely.
Another area where conflicts come up is in expert witnessing.
Yes.
You're supposed to be impartial,
Right.
but you're also being paid by one side.
Yeah. How do you maintain your integrity?
Good question.
The textbook says be upfront with your clients.
Okay.
Make it clear that your obligation to truth comes first.
So you're not just advocating for your client.
Correct.
You're an engineer first,
Exactly.
bound by that ethical code.
It's about honesty and integrity even when there's pressure.
And this idea of honesty ties into a broader discussion about informing the public. So it's not just being honest with clients and colleagues.
Right.
It's about transparency with the public as well.
The textbook says engineers have a duty
Okay.
to make sure people have the information
Right.
to make informed decisions about technology,
Especially when there are risks.
especially when there are risks.
Like when a company knows about a safety issue,
Yeah,
but tries to keep it quiet.
like the Ford Pinto,
Right.
a classic example.
They knew about that design flaw.
They did.
It didn't fix it.
They said it was cheaper to pay lawsuits.
They put a price tag on human lives.
It's a reminder of why engineers need a strong moral compass
Absolutely.
and the courage to speak up.
It's about being a whistleblower,
It is.
even if there are consequences.
Exactly. And this leads into another area the textbook explores,
Okay.
the relationship between engineers and managers.
Ah, yes, that classic clash.
Yeah.
Engineering values versus the business world.
What happens when a manager asks an engineer
Yeah.
to sign off on something unsafe?
Deadlines, budgets, pressure from higher-ups.
It happens.
But the engineer's responsibility is to safety.
It is.
So what do you do?
The textbook uses the story of Ernest Fitzgerald,
Okay.
fired by President Nixon for whistleblowing.
So he was punished for speaking truth to power.
It shows the importance of responsible dissent.
Right.
Standing up for your judgment.
Even when it's hard.
Even when it's hard.
Makes me think of Challenger again.
Yes.
Engineers warned, but were overruled.
Classic example.
Organizational pressure leading to ethical lapses.
The textbook has that quote.
Yeah.
Take off your engineering hat and put on your management hat.
It's chilling how ethical concerns can be pushed aside.
It is.
Makes you wonder how to create a culture where engineers feel empowered to speak up.
Yeah, where their voices are heard.
That seems crucial to preventing disasters.
It's an ongoing challenge.
It is.
But it's a conversation we need to have.
Absolutely.
And speaking of challenging conversations, let's talk about global engineering ethics.
Oh, yes. Our textbook has a whole chapter on that.
It does.
And it seems like that's where things get really complicated.
It is.
Ethically speaking.
Engineers in other countries encounter different norms and practices.
Like we said, nepotism might be okay in one culture.
Right.
But not in another.
Or gift giving.
Yeah, which could be seen as bribery.
How do you navigate those gray areas?
How do you balance respecting local customs with your own ethical standards?
It's a tough one.
Is there a right answer?
The textbook explores this.
Okay.
Sticking to your standards versus adopting local practices.
Right.
They suggest finding that creative middle way.
Right. Finding a way to respect other cultures while staying true to your principles.
It's a balancing act.
It is.
They use a case study. An engineer in a developing country discovers a factory polluting a river.
Okay.
But shutting it down would cause job losses.
Wow, that's a tough one.
It is.
Protecting the environment.
Right.
But also people's livelihoods.
It highlights the need for dialogue. Listening to different perspectives.
Right.
Thinking creatively.
To find solutions. That minimize harm.
And respect everyone's needs.
So global engineering ethics requires cultural sensitivity.
For sure.
And the ability to think outside your bubble.
Absolutely.
As our world becomes interconnected, these skills are going to be essential.
They will.
We've talked about trust, challenges with managers, and global ethics. It's clear engineers face a lot of dilemmas.
A lot of dilemmas.
So it seems like engineering ethics is really about how do you make decisions that benefit humanity, even when there are all these challenges and priorities.
It's a balancing act.
It is.
And the decisions are tough.
They are.
But that's what makes it so fascinating.
It is fascinating and important.
Speaking of fascinating and important, what's your final takeaway?
Oh, final takeaway.
For our listener.
If I had to pick one, I'd say engineering ethics isn't just about rules.
Okay.
It's about a mindset.
Okay.
A way of thinking.
Yeah.
That puts well-being and innovation first.
Okay.
It's about those tough questions. Thinking about the consequences.
Right.
And speaking up when things are wrong.
I like that.
Yeah.
Being proactive, not reactive.
Exactly.
Shaping the future.
Exactly. And it's not just on engineers.
Right.
We all have a role to play.
Okay.
We need to demand ethical conduct from the people who build our technology.
So be informed citizens.
Yes.
Have those conversations and hold engineers accountable.
Absolutely.
So it's a team effort.
It is.
Engineers with a strong compass.
Right.
And a society that values ethics.
Okay, so working together to make sure technology serves us.
Exactly.
Not the other way around.
I like that.
That's a great point to end on.
It is.
But before we wrap up,
I
have a question for our listener.
All right, shoot.
Imagine you're an engineer working on a project that impacts the environment.
Okay.
You've designed a sustainable solution, but there's still some trade-offs.
Right.
How do you weigh those? How much impact is acceptable in the name of progress?
That's the question every engineer needs to think about.
Yeah.
It's tough, but thinking about it.
It is.
That's what moves us forward.
It's food for thought.
It is.
It shows the need for dialogue, critical thinking, and challenging assumptions.
Couldn't have said it better myself.
Well, this has been an amazing deep dive.
It has.
Into engineering ethics.
We covered a lot.
We did, from the basics to real-world issues and global challenges.
Yeah.
It's clear that this is a complex field.
For sure.
That needs our attention.
It does.
And for those who want to learn more, we've got links in the episode description to case studies, the NSPE Code.
Nice.
And more.
Awesome.
Thanks for joining us.
It's everyone.
It's been a great conversation.
It has.
And we hope it sparks some questions for you to think about as you navigate your own ethical landscape.
Very cool.